y becomes 0 because e to the power of y also increases towards the maximum, right? So the 1 by a maximum value will be 0. So the probability as y increases means the marks increases, the probability is 1 means he will pass. The probability is he will pass. But let us assume if y decreases, if y decreases, sorry, y decreases. So what will happen? This e to the power of y, suppose e to the power of 0, e to the power of 0, e to the power of 0 becomes. So this is also going into the negative direction or negative direction. So this e to the power of y becomes, e to the power of y becomes means a maximum value. Sorry, a minimum value because if y decreases, so e to the power of y also decreases. E to the power of y also decreases. So it may go into the negative also. So 1 by some sorry 1 by what is that called 1 by some 0 means it will go towards 0 or negative values. So 1 by 0 this term becomes what? 1 by 0 is infinite. 1 by 0 this term will go to infinite state. So 1 by infinite. So at the end what will happen? The probability becomes 1 by infinite. So 1 by a maximum value, 1 by 1 plus infinite. So 1 plus infinite is not at all, is equal to almost infinite, right? So 1 by infinite, this becomes 0. So what is the observation here? As the marks are increasing, he is into the pass mode or pass grade. He may be in the pass grade. But if the marks are decreasing, the y value is decreasing, e to the power of y approaches 0. So 1 by 0 becomes infinite. So for a total of the numerator by numerator is 1 and the denominator becomes infinite. So this probability becomes 0. So here this is the status. So that's why based on the marks observed or based on this y value, we are converting this linear line into a sigmoid curve, to a S curve, a S curve. Now we'll apply some threshold over this. If the probability is, suppose here the probability is 0 here, is probability not marks, the probability P is less than 0.5, less than 0.5, less than 0.5, less than 0.5, you will fail. He is in the fail grade. Suppose like this, I can draw a line now, threshold, right? So the probability by using this sigmoid curve, now we can easily say whether a student will pass or fail. So this is the way of means getting the logistic curve from the linear line. Okay, so the logistic curve we are deriving from the linear line, that is why equal to mx plus c. So that's why the name is logistic regression, and we'll use this logistic regression for classification problem. Right. Now, any questions, please? Before moving on to that, any questions? If you have any questions, we'll see. Nobody, no one is asking questions means you know everything or you're not getting anything. Yeah, you want any hands-on or we'll continue with other concepts? Hands-on means some a real-time example we'll take and how we can predict the means how we can classify or how we can predict the salary or whatever it may be. Means using linear and logistic regression. Actually, I have some real-time data of that Titanic ship, so that so how many of them are survived means and how many of them are not survived based on the data available. Now we need to predict. Based on the data available whether a person survived or not. Yeah, some real-time examples are there. Either we'll see that or we'll going to other concepts. That is up to you. So here I want to explore this Titanic data set. Explore about the people, then who are survived and those who are not, because we have some statistics. Real-time. The data is available. So with today's technology, so answering those questions using some data analysis, right? So using some these techniques, logistic regression or KNN or something. Anyway, we want to show you using logistic regression. So because we have these like data like predicting the salary and whether it may promote or not, and that drive in Titanic data set. So what factors actually influenced for the people who survived, and what factors made means what are the factors that are due to that the Titanic ship was what is that disaster happen. Okay, so those things we'll analyze if you want. Otherwise, I will move on to the next topic. So you can also practice. So using some Google Colab, I'll share my code real time. You can copy my code uh, from your system itself, and you can run it using some snipper tool is there. So I'll copy my code. I'll share the link. So using that link, you can copy into your Google Colab and you can practice. No one is answering. So then I'll move on to this uh, hands-on session. Okay. Actually, here I'm using two data sets. Uh, this predicting the salary of an employee, as well as one more data set. This is head brain. Actually, these data sets are available in Kaggle, and most of the code also you can download from this Kaggle site. Okay, this is available for the beginners. Right. Okay, so here this head brain data set I'm using here. So based on the brain head size, you know, otherwise before to that, I'll show you. Right, salary data I'll take. So the first one is means in any machine learning problem, so we need to import the libraries, required libraries, this pandas, numpy, seaborn, right? The next step is importing the data set. So this is the data set I'm using, salary data, salary underscore data CSV file. This is a uh, uh, this is the data set I'm using. So this data set consists of age of the employee and his years of experience, and we need to predict the salary of the employee, right? So I'll show you that the data set.
Excuse me, sir.
Sorry.
Sir,
Yeah.
slides are not changing. Still, I'm seeing this sigmoid function.
Sorry. Right. Okay. Sorry. Because you haven't answered, sir, so that's why. Okay, I'll share my. Right now it is visible, na sir. That's this code.
Yes, sir.
Right. Okay. So here I want to demonstrate you so how to predict the salary of an employee based on his years of experience. So simple linear regression. In 5 minutes, I'll show you this demonstration. Okay. So right. Actually, this is a salary. First, the first step in any machine learning model is to import the packages, required packages, NumPy, Pandas like this, right? So the second step is importing the data set. So this is the data set I am using. So here I will show you what this data set will consist of. So salary data dot head. Okay, why? See, here we have two columns here. This is a serial number. Actually, years of experience is there, salary is there. So let us assume this is your institutional data, right? So if you observe here, here the independent variable, that is years of experience, right? This based on years, based on your years of experience, your salary will be there. So salary is the dependent, right? Whereas years of experience is independent. So here what I am doing, so this is the first 5 records of the data available. First 5 records of the data available. You can see here, suppose top 20 records also. This is the top 20 records of the data available here. See, see here, a person having 1.1 of 1 years of experience is having salary this much, 1.3 this much, 1.5 this much. So some data is available, real time data is available. Let us assume, right? Okay, then in the first step itself, what I did, see, from that salary data, this I'm reading this salary, salary, this data set into a variable called salary underscore data. Okay, so from that, I'm taking the independent variable data. Independent variable is what? Years of experience. Years of experience into X, because the independent variable should be in the X axis, right? So I'm taking the independent variable data, that is years of experience, into X. So what is the instruction here? From the salary underscore data dot allocation all rows excluding the last column. See this colon stands for all rows and all columns, but this colon here, sorry, this colon is here stands for all rows excluding the excluding the first column. First column means this is 0th column, this is first column, right? Years of experience is 0th column, and uh, and salary is in the first column, right? So excluding the, sorry, -1 means excluding the last column, right? So now X is having the years of experience, and Y is having, see here, Y equal to salary underscore data of allocation all rows and the first column. Here X data we taken, excluding the last column we are loaded. Excluding the last column means year of experience will be loaded into X variable, X array you can call it as, and Y will be loaded with the what? Salary data, right? So now using this X and Y, now we can predict. Sorry, we need to train the model first. So this is the X data and this is the Y data. Now just visualize this data. So just observe here. So we have of see, as the years of experience increases, as the years of experience increases, the salary increases, right? So here we are visualizing our data using a bar plot. I don't know, this may be covered by Venkateshwar Rao sir, right? This bar plot, these different types of visualization techniques, right? So SNS dot bar plot of X on X axis years of experience and Y is salary data, right? So this data is from the salary data we are taking, right? So this is the visualization. You can see here as the number of years of experience increases, the salary will be increases. So this is a linear problem, right? Now, in the next step in any machine learning model is splitting the data into training and testing. So for that, actually we have we have a function called train underscore test underscore split. So splitting the data, given data into training set and testing set, right? So this function we are importing from scikit-learn. Okay, scikit-learn dot model selection. We are importing this train test split. So now we are using this function train test split of x comma y, where x is the independent variable data and y is the dependent variable data, right? That is salary data. X is the years of experience data, and here I am specifying the test set size as 1 by third. Test set size, test data size as 1 by third. From the overall data, we are splitting the data into 1 by third of the data is for test set, and remaining 2 by third, that is 66%, 66.66% for training purpose, right? So so we are split this data into training function here. So again, I'm importing this linear regression function from the scikit-learn, okay, and I'm right. So this linear regression function, for this linear regression function, I'm creating an instance. Now lr dot fit, this fit function will be used for training. Okay, so training using what? Training data. So training data is in what? X train. This is X train means training data. See, LR dot predict. LR is the instance of the linear regression, and predict is the function over test data. So suppose this is the years of experience. What may be the Y values? What may be the salaries? What may be the salaries? We need to predict, because in the previous step we trained the model using our available data. Now for instance, if a new employee comes with some years of experience, 2 years of experience, what may be his salary, right? So this X test contains some test. So we need to predict this Y underscore predict, Y underscore predict, right? Now these are the predicted values. These are the predicted values. Right. Now this is the visualization actually for the training data and testing data. I think we have 30 records here. So 30 record out of 30 records, 2 by third for training. So that's why here 20 samples will be there. So based on the training, so this regression line will be drawn, right? Now for testing, the visualization of the testing is this thing for 10 samples, because the 1 by third of the samples were reserved for testing, right? So how close, these are the original test values, sorry, original y values, right? For these many years of experience in the X test data, the blue labels are the original salary, but the predicted salary is over the regression line. So how close this regression, original value is to the predicted quantity, predicted salary. So that is actually will be the means if that all these original values are closer to the regression line, then that model is very good, right? So the prediction is there. Now what is what you know. Uh, so you can also see here the y predicted values. So these are the y predicted values. So before to that, I'll show you this is print y predicted. So before to that, I'll show you the test values also. So we can compare. So y underscore test. This is see, these are the y underscore test values. So these are the original values. 37,731 is there. Before to that, I'll show you the years of experience also for what that. So x underscore test is the original years of experience. So here you can see for 1.5 years of experience, the salary, original salary for an employee in your organization is 37,731. But our model is predicting it as 40,835 rupees. That some here some expression is there. So 40,835. But the original salary is 37,731. So in the next case, the next input actually what we given is 10 years, 3 years experience. For that, the original salary y underscore test consists of the original values, right? So the original salary is 1,22,391, but our model is predicting it as 1,23,079. So there is a small variation, right? But it is predicting somewhat closer to the original data, right? So now likewise for a person having 4.1 years of experience, his salary, original salary was 57,081, but here our model is predicting it as 65,134. So here there is a variation of 8,000. Here there is a, in the second case there is a variation of 1,000. In the first case there is a variation of 3,000. So these variations should be always there. Now in the fourth case, 3.9 years of experience, his salary, original salary is 63,218, but our model is predicting it as 63,265 rupees. Very close. This is 63,218 and here it is 63,265. Almost only difference of 40 rupees. Okay. So like this, our model will predict the salaries. So this is a very simple example I taken, but actually the beauty of Python is that all these functions are available ready-madely here. Okay, you can simply use that functions by importing from the scikit-learn. But if you want to do using means from the scratch, it will take actually you need to write a lot of code. So see here, this for this example actually I taken I developed this I means I logistic regression model was developed from the scratch. See here, this is one more example. Importing the libraries that is common, and I'm reading the data into some data array. Data equal to pd dot read underscore csv. This is in my download. This is the path I given for that data set, and these are the first 8 records of the data set. Data set you can see here. The gender is there, age range, head size, and brain weight. So here the data available is like this. Based on the head size, what is his brain weight? Okay, as head size increases, brain weight increases. Okay, now if a person born with some head size, what may be his brain weight? So we need to predict that. Okay, for that actually again here the dependent is brain weight. Correct? We need to predict brain weight, right? Brain weight will depends on head size. So the dependent is brain weight. So that's why brain weight is loaded into Y array and head size is loaded into X array. See here. And then now here the next steps are for calculating. because we need to draw a line, right? Y equal to mx plus c. We have y data and x data. So from that we need to derive the m1c values. So to derive the m1c values, this is the code required actually. We need to find out the mean values of those x means dependent variable and independent variable, so that from where the exactly the regression line will passes. And we also need to find out the slope as well as y-intercept. So for that, these are the steps. Up to this, see here how many number of instructions are required. So this is the mean x value, this is the mean y value. Then I'm calculating the mean here, sorry, slope here, m here and c here, y-intercept and slope. Then this is the mean value in 52 and 53. 53 is the y-intercept value. Sorry, here in the line 53, this is slope value is 0.263 and the y-intercept value c is 325. So from that, here I draw, here we can draw a regression line, right? So now these are the data samples we taken, right? The 30 sample, sorry, head brain, this is having high, means lot of records. I think it's having 300 records. What? So this is the model built using the data given. This is the regression line we got. And so what is the error actually here? Always there is a means error will be there in while means developing a regression any model, right? So the error can be calculated like this. What is the original? These red dots are the original brain weights. Okay, but the predicted values will be always on the regression line, right? This is a predicted line, right? So the difference between the original and the predicted is the error. So always that should be minimum. The error should be minimum. So to find out that one, we have a set of methods: root mean square error, r square error, like that. So the minimum value is always the good model. Okay. So see, this much code is required, but with simple scikit-learn, same we can do using only, see here, uh, with the dot fit and dot predict. But we need to import the linear regression function, and we need to create an instance and use fit function for training and the predict function for testing, right? So that much easy with Python. So one more important thing is no need to remember the mathematical background about these models. Okay, we have ready-made packages available in Python as well as MATLAB also, in R also. Okay, so this is about linear regression. Now, uh, logistic regression. So before actually this is a lot of analysis is there. So I'll explain, because the first step in any model in any machine learning model is data collection, then data cleaning or data pre-processing. So why pre-processing is required and what type of pre-processing we need to do, I'll explain with a good example. But before to that, how the linear regression will work, I will show you with a simple example. See here again, this is logistic regression. The first step is importing libraries. The second step is importing the data set. Load the data set. Data set equal to pd dot read underscore csv. Read underscore csv is the function to load the data set. Okay, so data set is the array. So to where we are importing this data set. So what data sets I'm using here is social network, social underscore network underscore ads. Again, this is also available in Kaggle, right? You can download it and you can practice it. Right now, I'll show you. I'll show you the data set, few of the instances of the few of the records of the data set. Data set dot head. Where data set here is what? Is an array where we loaded our social network data set, right? So it is given the name data set. So data set dot head. See here. So we have this information here. So user ID, gender. These are the top 5 records of the this data set, social network data set, right? So user ID, gender, age, and the salary, whether purchased car or not, right? So in regression, what we addressed as previously, based on his years of experience, we predicted the salary. But here, based on his age and salary, we will try to predict whether he purchased a car or not. Whether he purchased a car or not, right? So suppose let us assume we have a real-time data is available. Let us assume from our institution itself, an employee with 19 years, maybe 19 years, no one will join. Minimum 25. After MTech will join, right? So minimum 25, but some real-time data from social network. A person with 19 years of age and his salary is 19,000. He he haven't purchased a car. Zero means not purchased. One means purchased. Suppose 10 records I will show you. See, this one stands for purchased. In purchased column, this one stands for he or she purchased the car. Zero stands for not purchased. Okay. So here this gender and the age is not at all a matter, because a simple example I am taking based on his salary, whether he purchased a car or not. That I want to show you. Okay. In the next example, I will show you with a lot of parameters. Means how what are the parameters involved to survive in that Titanic ship's disaster. Okay. Right. So this is the data available. Right. Age 19, 19,000 not purchased. A person with 35 years and salary is 20,000 also not purchased. Person with 26 years and 43,000 also not purchased. But you can see here a lady, female with age 32 and her salary is 1,50,000. She purchased the car. So this is the real time data we are available with us, right? Okay. Now the next step is what? We need to split the data set into training and testing, right? So what is our goal here? Based on his salary, salary is the independent, and dependent is whether purchased or not. Two classes. This is classification problem, whether purchased or not, right? Now, first the given data set is divided into training and testing. So again, for that we have a function called train test split from the scikit-learn. From the scikit-learn, we imported that. Then see here. Ah, so here I want to show you one more thing. Right, right. So here actually, you know, sorry, considered age also. Considered age also. See, in the X is independent, right? Based on his age and salary, we need to predict whether purchased or not. Okay, so that's why X array is loaded with second and third columns. So second and third columns are age and estimated salary. Okay, the index starts with 0, user ID is 0, gender is 1, age is 2, estimated salary is 3, purchased is 4. So 2 comma 3 columns are loaded into X here in the first step itself. Then whether purchased or not, that is loaded into Y. This is independent parameter, right? So then right. Now the next step is split the data set. Now X is having independent data and Y is having dependent data. So for this train test split, we are giving as parameters this X and Y. And we are also specifying the test set size as 0.25. So 1 by 4th of the data set is reserved for testing and remaining 3 by 4th for training purpose. Again, the data training data is an X train and Y train. The examples in training data of the examples is it X train and Y samples in Y train. Likewise, testing data is in X test and Y test arrays. Right. Now this is one of the pre-processing step feature scaling we are doing here. Why we need to do this feature scaling? Because you can observe here we are considering this age and salary as well as this purchase, right? So if you see a salaried employee's age is between 18 to 20, sorry, 18 to 60, 18 to 60, right? So the range is around, suppose let's say 20 to 60. The range from minimum to maximum is only 40. But you can see here the salary. some value 19,000, 20,000. Here one salary, here he is 1,50,000 also there. Now see the range 19,000 to 1,50,000, around 1,30,000, right? The range is very high, but here the range is only 40 in age parameter, right? So here the ranges are means they are not compatible actually. Okay, so to make it compatible, we need to do some scaling, right? So for that, actually this step, we are doing some pre-processing step that is called scaling operation over test data and training data, right? Using a standard scaler, right? So it will scale the data from 0 to 1. Okay, right. Now the next step is training the model, right? Splitting is over, scaling is over, right? Then we need to train the model. So for that, we need to have this logistic regression function. So we are importing this from scikit-learn again, right? So here in this step, we are creating an instance log R. Okay, we are creating an instance of logistic regression here that is called log R, and using fit function, will train the model using the data x train and y train, x samples and y samples, right? Right, 2 by 3rd of the data, right? 2 by 3rd of the samples for training, right? So now we train the model, right? The next step is predicting, right? So for predicting, we need to have age and salary, age and that independent values. So we one stands for purchased, right? Now we'll check whether how accurately our model, trained model, is predicting. Okay, so for that we can true positives and true positives, false positives, and false negatives and true negatives, right? That is a 2 by 2 matrix, right? So the confusion matrix, I don't know, I think. So here you can see this confusion matrix as output. This is array of this thing. Not purchased, right? But this secondary diagonal, these are the false positives and false negatives. This is the error. This is the misclassification points. The primary diagonal is the correct classified points or correctly classified inputs, and the secondary diagonal is misclassified points. So out of 100 samples, actually this data set size is 400, and 1 by 4th is taken for what is that called, testing. So out of the 100 samples, these 63 true positives and 25 true negatives, means these are correctly classified. So accuracy is 62 plus 88, sorry, 88 we are getting, right? So the confusion matrix you can see here, this is 88, and the prediction accuracy you can see here. The accuracy score also you can see 88. The prediction accuracy is also 88%. Means out of 100 samples, 88 samples are predicted correctly. Okay. So this is a simple example I taken for means explaining you the concept of logistic regression based on his age and salary. An employee purchased a car or not. Okay. So these are the correct predictions. 63 plus 25, 88 are the correct predictions, and and 12 predictions are misclassified. So the accuracy of the model is 88%. If you have any question, please ask. Otherwise, I'll explain this Titanic model, Titanic data set, how we need to do some pre-processing in that, and why pre-processing is required in machine learning. Okay, because to get okay, I'll explain that later. But if you have any questions, please ask now itself. 23:28. I'll take 20 more minutes, 20 to 25 minutes. I'll finish it. If you have any question, please type on the chat box or you can ask. No one is answering questions means no one is listening. Or you will know these concepts. Okay, now anyway, I'll right. I'll explain you mainly this data set. Actually, I taken to explain you how means the pre-processing is important for a machine learning model. Okay, this is the Titanic data set. Actually, this is the data set size is very big. 2,400 plus records are there. But here I taken only the data of 890 people. Okay, so here the first step is again common, right? For any model, importing the packages. The second step, yeah, what is the somebody is asking some question, standardization and normalization, right? So yeah, normalization generally, will if the incompatible data is there, generally we'll use this uh, we'll use this what is that called? What is that? Normalization, right? Because if whatever the example I shown you,
Yeah, sir, that salary data, we perform normalization, not
correct,
standardization.
correct, normalization we did, sir.
0 to 1 nothing but it's normalization.
Right. So
Yeah.
using scaling function, we did that using that feature scaling function,
But in the
or
code,
we
you
can also,
mentioned like standardization.
sir, code you
In
want,
the,
sir?
yeah, in the code, you mentioned like a standardization.
No,
Yeah,
no, no. Normalization only I said, sir.
normalization. Okay, okay,
Because maybe Mike some error. Actually,
okay.
standardization is also a type of normalization.
Normalization.
We'll call this one as Z score normalization something.
Yes, yes, sir.
Okay,
I
by
am not.
subtracting the mean feature by its mean and
Standard.
dividing by some standard deviation. Okay,
Yes,
right.
sir. Yes, sir.
Okay, so that is a pre-processing step because there is a lot of not there is no compatibility actually between that age and salaries. That's why, right? We did that. Okay, here we'll see a lot of those type of things, sir. Right. So the second step is importing. Loading the data set into this variable, or we can call it as array, train array. Okay, train equal to pd dot read underscore csv, and this is the path I am giving, and this data set is in my downloads. This is the data set is train titanic underscore train dot csv. Actually, this is also available in Kaggle, with two means training is there, testing is there, but I taken only this training data set, and again I split this training data set into training and testing. Okay, but you can use this one for training, and you can also take test data from Kaggle also, and we need to what you need to load into some other variable, right? But only using this data set, whatever the available 891 records. So I'm doing this experimentation because of this is demonstration only, right? Right now, after loading, just after loading the data into this array, train array. So I want to show you what are the different parameters, okay, of that data set. So here you can see there are a lot of parameters involved. Passenger ID, whether survived or not, what is the passenger class. So see here, passenger ID 1, 2, 3, 4, 5. So head will show you always the dot head. This function will show you top 5 records of the data set. Okay. So first 5 records of the data set. So 5 records. So the passenger IDs are 1, 2, 3, 4, 5, and whether they survived or not. Zero means not survived. One means survived. Okay. So the first passenger ID was died in that incident. Okay. Second passenger ID he was survived. He was alive. Right. So like this, this is there, and this is a passenger class. So first class, second class, and third class, like sleeper, sleeper first class, sleeper second class, sleeper third class will be there, na? AC, right? In everywhere it is there. Some right. So this is passenger class. There are 3 classes: 1, 2, 3, right? So likewise, name, passenger name, their sex, either male or female, right? And their age, and whether any sibling or parents are traveling along with them. The SIB SP stands for siblings or parents are traveling around along with this passenger. Okay, suppose with passenger ID one sibling or parent, okay, is traveling in that ship. Okay, this part I don't know and never explored, and I haven't used this thing. Okay, now ticket number. Okay, this is a ticket number, and this is the fare, that maybe in dollars or what means euros, or I don't know exactly, but some quantity. So 7.2500, and cabin, in which cabin they were there, right? So in every there are really cabins, right? So which cabin they were there, and embarked. So from which particular place they started their journey. Okay, there are 3 places. So this is Southampton, Christchurch, and one more will be there. I think some just I'll show you that. Queensland. Yeah, if you see 10 records, I'm showing here. So they boarding point. Okay, so into that ship, right? So this is the information available with us. Now we'll do some analysis on this. Okay. So before giving into the machine learning model, we need to do some pre-processing, right? We need to analyze first. Okay, what type of data is there, whether it is suitable for that model, means in suitable form or not. We need to do. Okay. So here the first I want to show you how many entries are there. Okay, so you can see here there are this information we can get using train.info. Train is the data array, right? So dot info. So here 891 entries are there. So the columns, 12 columns are there, and passenger ID. These are the fields or parameters, right? And the next step is you can see describing the data. So here, if you describe this, if you use this describe, see the count with passenger ID, the count, the number of values per passenger ID is 891 passengers are there. For survived information also, for all the 891 it is there. Passenger class is also available 891 for 891 people. But age information is available, the count, just see the first row, for only 714 people. Okay, and sibling information is there for 891, and I don't know what is this part. This fare information is also available for 891. Right now, the mean value, standard deviation value of these passenger IDs, the minimum value passenger ID is that, the maximum value is 891, and 50% of that, 75% of that, that information is there for some data analysis. Now, so generally in pre-processing, what we'll do, we need to identify some outliers, some null values, right? And one more thing, actually for machine learning model, we need to always give the numerical values, not text values, right? String values. Okay. So we need to identify those kind of things. Okay. So actually, lot of analysis we can do, but actually some small examples I'm taken here. First, I need to identify in this data set any null values are there. Any null values are there. So train dot is null. See here, is null if true, that is a null value. If false, that is not a null value. So if you execute this, we are getting this. We are getting this information for all the 891 records. So passenger ID false, false, false means is null is false means not a null value. But somewhere you can see here 886 record cabin information is true. True means is null is true means that is a null value. That information is not available. Likewise, for 888 record, the age information is not available. This is true. True means not available, right? So likewise, for second passenger also, third row, this cabin information is not available. This is true. For fourth passenger also, the cabin information is not available, right? So these are the some null values you can we can see in the data set. Okay, so actually we can visualize these null values using this heat map. See here, passenger ID, you can, I think you can see this, right? So lot of this yellow bars are there, right? For age and cabin, for age and cabin, right? So for age, you can see here there are this is not that much dense compared to cabin. So for, but for cabin information is not available for most of the users. So likewise, passenger ID, it is not at all a problem. Survived, P class, name, sex, not problem, but age and cabin information is missing for most of the records. Here already we saw here, right? Age information and this cabin information is not available for most of the passengers. Now this is some count plot. So how many are survived and how many are not survived? Right. So 0 stands for not survived and 1 stands for survived. Right. This is a simple plot. You can see here among 891, around 600 are not survived and 291 are survived. So among that, again we can also see based on sex, how many male are survived and how many female are survived. Okay, so the 0 stands for not survived. Most of the men are not survived. See here, compared to female. See, but here survived, in survived case, most of the females are survived compared to male. Right? This blue is male and orange is female. Right, based on passenger class. Also, generally the top class, Onion also consider a null value. Correct, correct. Right. So here, based on passenger class, also you can see here, uh, passenger three, actually zero stands for not survived. In uh, passenger class three, most of them are not survived. Just check here. It's green in zeroth case, left side. Passenger class 3, maybe it is cooked with most many people, or some, or it may be in the means danger zone, right? So generally see, likewise, in survived case, here, uh, is that class 1 as well as class 2, class 1 as well as class 3 approximately equal in survived case, but class class 2 are less survived. Okay, this is the age of the passengers who traveled in that. Okay, now we need to do this thing, data cleaning part. So those null values should be removed, right? So train is null, train dot is null. Already we saw here, lot of null values are there. Actually, these null values we can fill with the minimum value of that row, sorry, that column, or the maximum value of that column, or the average of that column, right? Suppose in age, some null values are there, right? So default, suppose 18 to 60 are there. Let us assume the average one, 60 plus 20, 80 by 2 or something. So 40 we can give, or minimum value 18, or maximum value 60 or 70 we can give, right? So here the age, you can see from 1 year to 80 years are there. This is the age plot, age on x-axis, and frequency, number of passengers with that age. So one, it is around 51 kids are there, right? Means 0 to 10, there are 50. There are 50 passengers are there. So 10 to 20, there are around 48. 20 to 30, or like this, the age groups are there, right? So now using this data, we can fill either with the minimum aged person, some null values are there, right? If the value is not provided, we can fill that data with the minimum value or maximum value or average or median or some other method we can use, or we can do some analysis for how many of, okay, some other analysis like some means we can use some other analysis also, fill those values. Now you
Sir,
can see, yeah,
if it is labeled data, can we
right.
replace with the mean and answer?
This is labeled data only, na sir?
But if it is labeled, then we cannot find the mean or maximum. It's
No,
numerical,
no,
we
no.
can replace
No,
with
no,
that.
no. See here, see age is numerical only, na sir? Here you can see age 22, 38, 26, 35. So here for the fifth passenger, see here, male, not a number. So this is not available actually.
Okay, sir. For numerical, we can replace with the mean or some. But what
Right,
about
right. Like
labeled
that,
data?
like that. Okay. So so this is the so here you can see, with the number of passengers, number means for which particular parameter the values are null. If you see here using train dot is null dot sum, you can see here for age. See here for passenger ID survived, zero null values are there for these parameters. But for age, you can see here 177 null values are there. Means out of 891 records, 891 people, for 177 passengers, there is no age value is available, right? And cabin information is also not available for 687 people. Okay, 687 out of 891 means this is approximately, 80, 75, 78 to 80%. Okay, most of the cabin data is, for the most of the passengers, the cabin data is, most of the means more than 80% is not available. So no use to use this data in our analysis part. Sorry, means training part or whatever it may be, right? So that's why simply, actually, if the data is more than most of the data is not available, it is better to skip this particular parameter. Okay. But you can see here age data is not available to, let us assume 200 people out of 175 people out of 900. So this is around 20% or 17%, 15%, that 15 to 20%. Okay, so for few people the data is not available, so we can fill this with some what is that called, based on these parameters, min, max, or average, or what. Okay, so this is the analysis. Now here, this is the heat map already we saw, right? But now after removing these null values, I will show you. So how this heat map will be, means we can visualize. So now this is the top 5 records. So from this, first I am deleting the cabin parameter, right? Because more than 80% it is the data is not available. So simply use del of this, from the training data, right? So from the data set, skip this parameter cabin. This cabin data is we are deleting this cabin data. Delete train of cabin, right? Now, actually, this is the here in the above table. You can see the cabin data here. Not a none, not a null. Sorry, E85, not a null, not a number. Sorry, not a number. So like this, right? Uh, but now, if after deleting, you can see that what is that cabin information is removed. After fair, it is cabin, right? But here directly we have embarked, right? So the cabin information is become what is that removed from the data set. And here simply here one method I am using, simply dropping that particular row, that is a, if a particular information, age information is not available. Okay, this is simple method, but you can use other methods too. Right now, check is there any information with the null information is there. See, for all passengers, now you can see the data is available, every data is available, right? The age information is available, fare is available, embarked is available, everything is available. But after see, after dropping those records, the complete record I removed. Okay, because right, so after dropping means I have only 712 records out of 891, because 177 records are not available for age and 2 records are not available for embarked, right? So those records I removed, but removing is not a correct process, but simplicity just right, just removed, and out of that now we will have 712 rows and 11 columns, because I also dropped this cabin information, right, out of 12 columns. Now this is the heat map you can see. So no gaps, right? So everything is filled. Now you can check this sum also. Is there any null information? Train is null of that sum values, all zeros. No null values are there, right? Right. Now one more important thing is you can see here in the data set. See, where is that? Sex, male and female. Okay, this is strings, right? So for machine learning model need to give this these numerical values. Okay, so to do that I'm doing some data manipulation here. So that particular column I'm splitting into two. Okay, so by using some by creating some dummy column, see, using pd dot get underscore dummies over sex column. Okay, we have actually sex column, right? So in sex we have two values, that is male and female. So using that male and female, now I am creating two different columns, right? So see here, pd dot get underscore dummies. So get the dummies is used for is data manipulation to create other dummy columns, right? Using this data, sex data, right? So now we got here the male and female, whatever the data available in those particular table will become the parameters. Here, see, these are the user data, right? Zero, sorry, this is 0, 1, 2, 3, 4, 891 records are there. Later on, I think I'll remove these because we need to consider only 717 records, right? So I'll do that later. But first I am converting this one into two columns, female and male. Now female, the first user, 0 stands for not a female, 1 stands for male, right here. So here first user 1 means female. In the female column 1 means that is female. In the female column 0 means not a female, right? So second user also female. 1 stands for female. If she's a female means that particular person is a female only. Means the male in the male column it will reflect automatically 0, right? So if this is 1, if female column is yes, then he is not a male. She is not a male, right? So that's why you can observe here they are either 0 or 1, either 1 or 0, 1 or 0. So after creating this thing, now I'll remove the one of the column from this. Okay, so from this pd dot get underscore dummy string, drop the first column. The drop the first column means the first column is what? Female information, not required, because male, if male is there, 1 stands for he is a male, 0 means she is a female, 0 means she is a female, right? Is not a male, right? So that is required. So that's why again I'll use this drop the first column equal to true. Drop the first column equal to true, so that we'll have only male means the parameter or the parameter will be represented instead of sex. Now it is converted into male, right? Male, whether male or not, right? This is sufficient. Now likewise uh, right, you can see okay, not required this one, the top 5 records of this, either male or not. And now embarked information, you can also see the boarding points, they are either Southampton or Christchurch or Queensland, right? So three different values are there, three different values are there. Again that is a string, right? So we need to convert into so what I'm doing, I'll create again three different columns for that. I'll finish in 2 minutes. Right. So this process will be repeated for this embarked and the particular. Now this becomes CQS, Christchurch, Queensland, and Southampton. Whether this passenger starts from either C or Q or S. So he started from Southampton, right? So first passenger, either like that we will have now created two dummy columns, and we have this information. And again these three columns are not required, right? Suppose if you remove in either of the two columns, we'll have the complete information, right? Either that may be 00 stands for that, in the third column it may be he may be started, right? So if we started from the first column, remaining two are not required, right? So like that's why again I removed this first column, that is Christchurch. Now the information is available to QS. So the 08th person starts from Southampton. The first person has not started from Christchurch, and Southampton means he started from Christchurch, right? So like that, kept only two columns. Now likewise, uh, this passenger class also 1, 2, 3 are there, right? So 1, 2, 3 are there. From that, again in this particular instruction only, dropped the first one. So we'll have the complete information of that passenger class. Now what we need to do? We need to add, because we converted this data into some suitable form using some pre-processing method, right? Now actually that sex is converted into male, right? And that information I stored in, see here. Uh, right, that information is stored in here sex array, right? So now I'll concatenate this sex information and this embarked information and this passenger class to the original train data, right? So for that PD dot concatenation of these particular fields, now you can see these fields are concatenated. Now these fields are concatenated, right? So see male QS, right, and 2 comma 3 passenger class, right? Now this information is not required, right? What is that? Sex, age, and this passenger ID, this embarked name, all this information is not required. Now I'll drop those columns. So after that, after dropping, we are having all the numerical values you can see here, whether survived or not, the passenger class, right? The passenger class also we need to remove, we need to drop. In the next step, please drop passenger class also drop. Train under drop passenger class also. I think this sibling information is also not required. So those will also be dropped. Survived, okay, class, okay, that taken, right? So after that, now we have this data is available with us now. Survived, age, whether sibling information, this I don't know, never I watch. The fair information and whether male or not, whether started from Queensland or this information is there, passenger class, etc. Now we need to what, now that the data we need to, x data we need to divide into x data and y data, right? Means dependent data and independent data. So what is the dependent data here? Whether survived or not, right? Survived or not, we need to do that, right? So whether survived or not depends on age, based on their siblings information, because they may protect sometimes, right? Based on their class, based on their what is that, boarding point, based on their gender, right? So that's why this information, the survived, will be taken into dependent parameter. That is y, and the remaining information x equal to train dot drop survived. Okay, so that is moved into the x. Except survived, the remaining data, the independent data will be taken into x. Then the next step, we just split the data into train splits, train test split, and we are specifying the training testing data size as point 3 means 1 by third, and we are importing the logistic regression function, creating an instance using the fit function over the training data set. We train the model, right? Then using the predict function, will predict the accuracy of the, what is that, trained model, right? So this is the using what is that, no, precision recall classification report. So the classification report over the original data, y test original data and predicted values will be given to the classification report. So these are the precision and recall values we got, and F1 score support all these things. Now you can also see the confusion matrix. This is very very important. So see here, confusion matrix. So true positives are 105 and true negatives are 63. So this is the correct classification, right? This is the correct classification, 105 and 63, and misclassified are 25 and 21. So 45, 46 records are misclassified, right? So the accuracy score you can see 78%. Out of 100 records, 78 records are 78 samples are correctly predicted. Okay, 75 samples are correctly predicted, and 22 samples are incorrectly predicted. I think 200 records are there here. 6, 8, okay, not 200 exactly. Out of, so this is the way of doing some data cleaning and data analysis with means some means real-time data sets. Okay. A sample example, but you can explore with other examples also. More lot of the data sets. So recent data sets, whatever. Suppose the people who worked on recent data sets are some challenging data sets. They are available in Kaggle, uh, or you can also download them from GitHub, right? The code also available. Actually, I also taken this code from GitHub, okay, for explanation purpose. So you can also try with a lot of codes available and the real-time data sets available. So to get some to explore these particular concepts. Yeah, if you have any questions, please ask. I think it is 4-3. Yeah, NaN actually in the original data set, that is a null value because while in Python we are printing, there is no value at all, means there is a blank. So that's why it is printing as not a number, simple, an empty space it is there. No, because my Excel is not working properly. I want to show you that real data set, but you can also real data you can see Kaggle. Yeah, meanwhile, if you have any question, you can type in the chat box or register for this first. Yeah. So yeah, here what I said, train data set is there, test data set is there, but only I taken train and split it to two. But you can train using this train data set and you can test using this data set description. Yeah, code is, you can also see the code here. Lot of code with Kane and with all now recent deep learning algorithms also, means you can, the code is available as well as the data sets what they use also available. So if no questions, then we'll stop for today. So you need to register for that. Need to register for means initially in Kaggle. Then you can download anything. Later you can sign in and you can download. Next session will continue with some other supervised learning algorithm. So how you can improve the performance, how they will work. Okay, thank you then. Sir, are you there?
Thank you, sir.